Welcome to the best math class in the world, Ava's awesome Math 3283W lecture, Introduction to Set Theory and Notation. So first thing I'm going to do is go over some vocabulary, kind of thinking about what everything would look like visually, and then we're going to go into our proof of one of De Morgan's laws. First we have x is an element of A, x, let's call that me, and A is being an awesome teacher. We would say X is an element of A, meaning that I am within the realm of being an awesome teacher, which I would say is true. So, great, we've defined that.
Exist within A. Moving on, we have X exists in, if you think about everything here in parentheses, X exists in the intersection of A and B. That's what this symbol means. X exists in the union of A union B. So that would be X can exist in A or B. We have X exists in A minus B. So that would be X would be every part of A that B does not touch.
We're going to use all of our definitions to go through a proof of a De Morgan's law question. So kind of using everything we just learned and putting it to practice. And to prove double containment like this, you have to first show that the left-hand side is a subset of the right-hand side, and then the opposite of that. So the right-hand side is a subset of this side. Here, X exists in A and X does not exist in B. So here we have X is an element of A and X is not an element of B intersection C. So everything here in parentheses, we're to describe this as, well, X exists in A. We keep that, but if we're just calling these B and C and X does not exist here, X cannot exist in B, or X cannot exist in C. X does not exist in B, then, okay, X must exist here. Without the intersection, that's great. Now, on the other side, if X does not exist in C, then X must exist in B without the intersection of C. And that's exactly what we want. So, because X is an element of A, and either of these two things can be true. X exists in A, X does not exist in B, or X exists in A and X does not exist within C. And now we've gotten pretty close to the right-hand side here. We can just rewrite this using our definitions over here. We know that means our union, as we kind of drew out over here. So then we have X exists in A minus B, like we said over here, or X exists in A minus C, meaning we have achieved what the right-hand side looks like. Now we know that the left-hand side is a subset of the right. Okay, so as discussed, I have shown that the right-hand side, now the left-hand side, is a subset of the other side. So just kind of went through that proof, and because we have showed that each side is a subset of each other, we have described that as double containment, meaning that they are the same space, and we could also see that visually in our Venn diagrams all the way up there. So that is De Morgan's law and how you can kind of manipulate the symbols here to rearrange each side to get it to look like the other, and that is the fundamental principles of what you're going to do to solve a bunch of other questions down the road. So I hope that was helpful, and have an excellent weekend.